All right, guys, what's up? So we're going to start Unit 3, which is acceleration. A lot of the stuff in the beginning of this video is going to be a review from last unit because we're going to be talking about velocity. We're going to be talking about displacement, distance, and speed. But it's going to be going forward. This is what we're going to be doing. What's up, Mr. McGee? Good? You don't look good. Yeah, I know. You told me. Okay. Uh, that's what I was gonna do that. Okay. Yeah, so Mrs. Claire, I think, is at lunch. Um, yeah, they should be right back. So, sorry about that. Sorry about that interruption. Acceleration, velocity, distance, speed. We're going to really start the big piece of kinematics now. And we're going to start with 1D motion, and then we're going to go to 2D motion, and we're going to be able to figure out all kinds of different things. It's going to be fun. And we're also going to be talking about gravity and some other stuff. All right, so every measurement needs a partner. You guys know this. You know how I am. No naked numbers. You gotta have your units and make sure you're using the correct units. Mass must be measured in some form of grams. The smaller it is, it can be in regular grams, decigrams, centigrams, whatever. Larger masses, like myself, should be measured in kilograms. Okay. Velocity, usually meters per second. Sorry, with a directional because it's a vector. Remember that, vector velocity. And then speed is scalar. All you need is a number. And usually in short trips, we use meters per second, whereas longer trips, it can and will be measured in kilometers per hour, or for us American, miles per hour. And an acceleration is always measured in meters per second squared, and so is gravity. And gravity is always measured in meters per second squared as well. So that means if you're given a problem with different units for either, you must convert it into meters per second squared. If you don't, you're not going to be able to figure anything out. All right, so quick review. Velocity. What is velocity? Velocity is an object's speed in a certain direction. It's got both components. Both of those components need to be there because it's velocity. As you can see right here, 100 kilometers per hour eastward, 80 meters per second southwestward, 70 centimeters per second southeastward. So velocity must have both the number and a directional. If it doesn't, then it's wrong, right? If it only has a number, it's speed. It's not a velocity. But if it's asking for velocity and you don't have a direction, the answer is wrong. All right, so what else is velocity? Velocity can be both positive and negative. Remember, moving up, it's positive. Moving down, it's negative. Moving to the right, it's positive. Moving to the left, it's negative. Okay? So, remember this DST chart? Distance is over speed or distance over time, depending on what you're solving for. How do we calculate velocity or speed? We use the equation distance over time. Okay, we have to make sure all of our units are what they are or what they need to be before trying to substitute and solving for velocity. All right, so some new stuff. Acceleration. We've talked about acceleration already, guys. It's a change in velocity. It can be one of these or it can be both of them. If there's a change in the speed or magnitude, that's a change in velocity. That means some sort of acceleration is taking place. If the number stays the same and the direction changes, that's a change in acceleration or a change in velocity. That means acceleration is taking place. Or if both the number and the direction change, then that's a change in velocity and acceleration is taking place. So acceleration is the rate of change in velocity. Acceleration refers to either the speeding up, slowing down, or change in direction of an object in motion. All right, so let's look at these charts. You already know these charts. You've seen them before. You saw them in the last unit. These are distance time charts, okay? Distance time chart, A, distance. This isn't moving, okay? The distance is not changing what's been covered over time, so this is not moving. This is moving at a constant rate. There is no acceleration on a distance time chart here because it's a diagonal and it's moving in a positive direction and a positive speed. This is moving in a negative direction and moving back to the origin. What's up? What? Okay. You got to talk to Mrs. Claire. All right. I think she's at lunch. All right. You got it, bub. All right. So this D graph down here, this graph represents positive motion and positive acceleration. So the velocity is changing. You have a curve. You know right away that there is some sort of acceleration taking place. This is still positive motion, but it is decelerating over time because it's starting to flatten out. And then this one again, constant rate of speed. So really no acceleration really, okay? Constant rate of speed, but at a slower rate than what graph B is. Okay, so looking at this. So here we go. Where does positive velocity take place? Right here, positive velocity is going to take place until this football reaches its apex. Okay, and the top spot is the apex. And the reason we call it the apex because it is the top, but it's also a spot where the ball for a microsecond will not be moving either left, right, up, or down. It comes to a complete stop. All right, what's up? Okay, I'll take it. Thanks. Okay, so where does positive velocity take place? It takes place at the beginning because the velocity is going, it starts out constant. It's still in the positive nature, but it is slowing down. Okay, so where does negative velocity take place? After the apex. It's coming down. What's working on the ball? Gravity is working on the ball. So is there any spot on this chart? Is there any acceleration? Yes, there is acceleration. There's deceleration here. And then you have acceleration taking place here, but in a negative direction. Okay. And the only spot where there is no instantaneous acceleration is right here, where the ball has come to a stop at the apex for a microsecond. So you have acceleration here. It's slowing down. It's working back against the ball. Okay. And then you have acceleration with gravity taking over here. So it's accelerating as it gets to the ground. All right. I know you didn't ask about trying to figure out for acceleration, but while we're here, we have nothing better to do. So the equation to determine acceleration is the delta of velocity, the change in velocity over the change in time. The change in velocity is VF minus VI, or VO, original velocity, over the change in time, which is the final time minus the initial time. Okay? So we have 5 vocab that you need to know. Acceleration due to gravity. Acceleration of an object that is subject to the force of gravity is close to the surface of the Earth. The acceleration is going to be negative 9.8 meters per second squared, or 9.8 meters per second squared. Okay? Then you have average acceleration. Average acceleration is the change in velocity divided by the time over which it changed. Usually we're talking about a trip at that point, right? Or at least to the halfway point. And then if you're slowing down, we're going to talk about that later. Constant acceleration is acceleration that does not change with respect to time on a velocity time chart. Okay. All the points are going to be the same. All the slopes are going to be the same on that line because it's constant. Remember, that's usually the diagonal that we see. Instantaneous acceleration is the rate of change of velocity at a specific instant in time. Okay. And then negative acceleration in the negative or opposite direction, or the slowing down of an object. Could be negative velocity coming back down to Earth, but it's accelerating in a positive nature. So think about that. The football gets to the top. As it comes down, it's a negative velocity coming back down because it's coming down, but the acceleration is positive in nature. As the ball goes up, the acceleration is negative because the ball is working against gravity and gravity is pulling back against it. So the acceleration is negative or slowing down, also known as deceleration. Okay. So there's 5 kinematic equations. I will always give you the equations before you even ask. So the first one is, let's talk about what each one of these stands for. VF is final velocity. VI is the initial velocity. A is obviously acceleration. T is time. D is distance or displacement. So equation one, when you don't have distance, this is the one you got to use to be able to figure something out. Equation two, when you're not given final velocity, this is the equation to use. If you don't have time, equation three is the equation to use. Equation four, when you don't have acceleration, you solve for whatever you're solving for in using equation four. And then finally, equation five, when you don't have the initial velocity value, you go to equation five. Okay? And I will always, again, like I said, give you the equations. So gravity. Let's talk about gravity. Gravity acts upon everything around the Earth's surface, including objects that have been dropped. Okay? It can be kicked, could be dropped, could be thrown, whatever. Gravity works on everything. It's what keeps us on the ground. Okay? I know everybody thinks it's my weight that keeps me on the ground. No, it's gravity, even though I am fat. All right. So any object that is dropped and only acted upon by gravity is said to be in free fall. Okay? Any object that is dropped and only acted upon gravity is said to be in free fall. You're going to see a picture of that later on. Two characteristics of the objects in free fall are: objects in free fall do not encounter air resistance, so that means there's nothing pushing against it, and all objects in free fall accelerate downward at 9.8 meters per second squared. Notice I use the word down, that's my directional. I could also say all objects in free fall accelerate at negative 9.8 meters per second squared, because the negative would also determine the directional. Okay, so that's gravity. So looking at this, gravity takes its toll around the Earth. Okay, looking at this ticker tape, and you look at this image, it depicts free fall. It's called a ticker tape trace or a dot diagram. You can see the guy at the top of the cliff has the ball in his hand and he drops it. Okay, so what do you notice in this chart is that the ball's close together at the beginning, and then over time, each one of these balls, so 0's in his hand, 1 second is here, 2 seconds, 3 seconds, 4 seconds, 5 seconds. Okay, you just drops the object. It's not thrown. It's going to be in free fall, and it's going to accelerate downward according to gravity. Okay, and the way we know that is we can look at this here. Your time is 0, so your velocity is 0. Your time is 1 second. If it's accelerating at 9.8 meters per second squared, at 1 second, the velocity is going to be 9.8. But at 2 seconds, the velocity is going to be 19.6 because it's accelerating at a constant rate. So at 2 seconds, it's 19.6. At 3 seconds, it's another 9.8 added to 19.6. You get 29.4. At 4 seconds, it's going to be 39.2. And then finally, at the bottom, at 5 seconds, it's 49. So you can see it's picking up speed as it goes down because the acceleration is 9.8 meters per second squared. Okay. Gravity is only that value on Earth. Other planets have different gravities. They change depending on what the atmosphere is and what the mass of the planet is. Adding time and velocity, you can now see how an object in free fall will behave. Okay. And looking at these free fall graphs, okay, position time graph. It starts very slowly. And then over time, gravity starts to take over. It starts to accelerate. It's accelerating positively, but the velocity is going to be negative in nature because it's coming back down. Okay, so velocity starts slow and then gains in velocity with a large negative downward velocity. Here, you have a velocity time chart, and it's moving. You've dropped it again off the edge, and it's going to be, the acceleration is going to be constant over time, but the velocity will change. So the object's moving in a negative direction, is speeding up, and is said to be moving in a negative acceleration because it's moving downward as opposed to upward. A constant negative slope equals a constant negative acceleration. So happy Tuesday, y'all. How do we solve these problems? We do it through consistency. Okay. And it's consistency that's going to allow you guys to be able to do these problems and do them easily going forward. You're going to do the same thing every single time. All right. Step one, examine the problem. Figure out what's happening. This is where you sketch out what is happening, determine the plus and the minus, and label it. Okay. And then step two, you're going to make a chart and list of the kinematic variables. Okay. When you make those kinematic variables, they are displacement, time, acceleration or gravity, initial velocity, final velocity. What I do is I make a chart of, it looks like, it's just like the DST charts that we made. Okay. And I will always give you this chart, just like I will always give you the equations and displacement. So this is what the chart will look like. And you need to make sure that you fill it in. And once you get to two-dimensional, you'll have to do one for vertical motion, the other one for horizontal motion. I know it probably looks backward, I don't care. But that gives you the idea of what the chart should look like, okay? Step three. Step three is identify and fill in what you know from the word problem. Do this step every time. So just fill it in. You'll get a point. Even if you don't solve the problem, if you are given three things in the problem and you fill them in on the chart, you get 3 points. The other part of this is in step one. So we got to go back because I forgot about it. In step one, you also need to determine you need to make a chart of what's happening. So every time, if you don't do it, it's going to be -5 every time. So you need to label your positives and negatives and just draw what's going on. So 4, identify the unknowns and what exactly are you going to be solving for in the problem. In other words, answer the question. What do you have to solve for? Step 5, figure out what equation to use based on what you're given and what you need to solve for. Then substitute your known quantities from your chart into the equation and solve for what you need to solve for. In some cases, you might have to use 2 different equations to get to what you need to get to. All right. And step 7, make sure you have no naked numbers. Include your units in your answer and make sure it makes sense and that the units make sense. And if you're solving for displacement, your units should cancel out to become meters, kilometers, miles, whatever. All right. And then a roller coaster's velocity at the top of a hill is 10 meters per second. Okay. 2 seconds later, it reaches the bottom of the hill with a velocity of 26 meters per second. What was the acceleration of the coaster? Okay. So the first thing you're going to do, and I wish I could do this while I'm recording, but apparently I can't. You're going to draw your roller coaster. So you're going to draw your graph, draw the hill, put a roller coaster up here, put an arrow going down this way, and put a roller coaster down here. Mark this as 10 meters per second up here, 26 meters per second here. Moving to the right is positive. Moving upward is positive. Moving downward, the acceleration is negative. Okay. So I said, I'll always give you guys the equations. Where are they? We can't do problems until we have the equations to choose from. So here we go. D equals di plus vt, or v equals d over t. Okay, if the initial distance is 0. Vf equals vi plus at, or if acceleration just equals v over t, if vi is 0. Okay, so here are all your equations. So when we go back to this question, this is your initial velocity. This is your final velocity. This is your time. You're solving for acceleration. So Vf equals Vi plus A times T. So Vf equals Vi plus A times T. That's what you're looking at. That's the equation that you're going to use. So now you're going to substitute your initial velocity. You don't know what A is, and your time is. So So 26 meters per second equals, as you can see right here, 26 meters per second equals 10 meters per second plus 2a. Now just solve. It's algebraic. Easy algebra. You're left with 2a divided by 2 seconds, and you're left with acceleration equaling 8 meters per second squared. There you say it. Okay, divide by 2 right here, and then you get up with 8 meters per second squared. Bye. Okay, so that's how you do it. We're going to do a bunch of sample problems that I will put on a video tonight. I'll actually have a whiteboard that'll make sense, so you'll be able to see it. Or actually, I might just do a whiteboard on Zoom. So it's pretty easy. Don't sweat it. Make sure you watch this. When you've watched this video, you need to watch this video tonight. You need to send me a direct message in Google Classroom. Do not put it on the stream that you watched it. If you don't do it, I'm giving you a 0. Okay? I'm going to give you a 0 out of 10. Watch the videos, because not everybody's watching the videos, and you need to watch the videos to be able to understand what's going on. That's the only way an honors physics independent study is going to work. All right? So that's it. That's all I got, and we'll be able to do kinematics going forward. And God, Frankie Marchese is an absolute pain in my rear end right now. There she is. Look at her being a pain, annoying me in this video. All right.